This is the solution for question 7 in the homework 3. Now we first have a look at the question. It provides us the zeros at z1 equals 1/3 and z2 equals 3 and a double pole at z0 for an LTI system. So we can write firstly write the basic equation, basic expression of the hw3 in this form. That is k multiply z minus the upside of this is based on the zeros, and the downside is based on the poles. So and the question A asks us to find out h of z if the DC gain is to be 1. From the lecture, we have known that the DC response is the output when the input is x of n equals 1 for all the n. So we can write the basic expression into this because when the input is 1, so we let the z equals 1. So we write, we can get minus 4 divided by 3 multiply k equals 1. So we can get k equals minus 4 divided by 3. And then we can easily get the expression of h of z. Question B asks us to find out the impulse response of the stable inverse system. So at first, we can reverse the system, and we can get the expression g of z at first. So the g of z will equals the k multiply the z squared divided by z minus 1/3 multiply z minus 3. Now because we want to get the impulse response, we need to transform the g of z into g of n. So follow the steps. We can first make the g of z divided by z to write the g of z divided by z, and we can separate into two parts according to the fraction. So it can be we can get this expression, and the C1 and C2, and at this time we don't know, but we can afterly find out the C1 is equals to this part when z equals 1/3, and after calculation we find out that C1 equals 1 divided by 6, and C2 for the same reason C2 will equals minus 3 divided by 2. So now we get the separate form, separate expression of the g of z is this. Because we want the inverse system to be stable, the ROC will include the square when the radius equals 1. So the ROC will be the area that the solution of z is larger than 1/3 but smaller than 3. So now we can do the reverse z transform to the g of z, and we can easily get the g of n is equals to this expression, and the ROC is this.